Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. So today we're going to look at the inverse of a square matrix. And of course, we are going to concentrate on 2 by 2 and 3 by 3 matrices in that specific order. So in this case, before I proceed, I'd like to appreciate our new members and also like to welcome more. And also I'd like to encourage us to visit various description boxes for specific links. They are going to contain links which have got discussions on similar topics. Now, in our discussion today, we're going to look at a specific strategy of finding a matrix of a square, of course, a determinant of or an inverse of a square matrix, and we're going to use, of course, a range of ideas that we have discussed in our previous, of course, videos. And this basically is going to be the concept of an adjoint of or the classical adjoint of a matrix that we are going to use at somewhere in our, of course, along our discussion. Now, in this case, I'm going to have this specific matrix represented in terms of A. So we're going to let our square matrix be given in terms of A. So the square matrix A is going to be referred to, or it can be referred to as invertible. All right. So in this case, it can be given or referred to as invertible if there exists, if there is another matrix B, in a sense that if we have the product of A and B, which is equivalent to B and A, then this is going to give us the product of identity. So therefore, we're going to have this specific I given as identity matrix. So this is one of the properties of multiplication that we're going to exploit in trying to identify this specific aspect of an inverse. And therefore, we have said that if we have a matrix A, one of the characteristics of this matrix is that it's invertible. We can have another matrix B in a sense that if we multiply A times B using this specific commutative property, then we're going to see that we're going to get a product of identity. So in this case, I'm going to have a specific matrix, and we're going to have this particular aspect of multiplying the two and try to identify or try to see whether this basically is going to be the case in case we do a multiplication. Therefore, we're going to define this second matrix B as the inverse of A, and this is going to be given in terms of A, given that specific notation of a -1 as such. So therefore, whenever I'm going to use this particular symbol, I'm going to refer to as the inverse of a matrix. Now, in case we have a value of n by n, where n is equivalent to 2, I can give the inverse of this specific matrix using a specific formula, whereby we're going to have this inverse of a matrix given in terms of 1 over A D. So that's a product between A and D, and minus BC, and that's a product between B and C. And this, of course, is going to be multiplied by D minus B minus C A. So basically, this refers to if we want to find a matrix of a 2 by 2 matrix, which is given in terms of A, B, C, D, we can have the inverse of this specific matrix defined by having it as 1 over AD, which is basically from this matrix. So let's have our matrix A defined as A, B, C, D. So these specific elements of the matrix then therefore can be used in order to find the inverse of this matrix by a product, the difference of a product of these diagonal matrices, a diagonal element of the matrix by having AD, the product of AD minus BC, which is going to form our first part of this specific inverse. And then this is multiplied with these specific elements interchanged to take the position. So A, in this particular case, then therefore, this is going to take the position of the diagonal element, respective element, and therefore A is going to take the position of D. And in that respect, of course, we're going to have B and C maintaining their position by their specific, of course, signs for the positive and negative are going to be opposite. So in this case, if it was B, C, then therefore we're going to have negative B, negative C in that specific order. And this specific formula then therefore is going to give us the inverse of this matrix A. And we're going to look at specific properties of these matrices, of course, which are going to be handy in assisting us understand the various operations that are going to be involved insofar as inverses of matrices are concerned. So the first one, we're going to see that if we have a matrix A, so basically we're going to use A as our a matrix for reference. So if we have a matrix A, which I've basically given in terms, if n is equivalent to 2, can give just an example of A, B, C, and D. And therefore, we can have specific rules defined whereby we're going to have a matrix A times its inverse is equivalent to the inverse times the matrix, and this is going to give us identity. So therefore, we're going to see this as specific commutative property being explained, or rather being given in this particular formula. And therefore, this one going to form one of the properties that we have already mentioned for the product between A and B is equivalent to BA. And of course, this is going to give us identity. And then next, we have said that if we have a product AB and we are requested to find the inverse, this is equivalent to the product of their specific inverses given as the inverse of B, inverse of A in that specific respect. And then number 3, we're going to look at another property of the inverse, whereby if we have an inverse of A, and then we're going to have a transpose of this specific inverse, we're going to obtain the transpose over that particular inverse, and then find the inverse of that transpose given as such. And then number 4, we're going to have another rule of matrices. If we have an inverse of A given as such, and we are requested to find the inverse of that inverse, so this is going to give us the specific matrices that is subject to that specific inverse. And then we're going to find that in case we have this is going to be the determinant of a matrix. This one can be given in terms of 1 over the inverse of the matrix given as such. So these are some of the properties of matrices that we're going to come across. And of course, we're going to, in our subsequent videos, we're going to look at some of the specific examples, especially of a 1 or a 2 by 2 and 2 by 3. But in this case, I'm just going to give a simple example of a 2 by 2 matrix and try to perform the operation of finding the inverse. And that is going to form for us our last bit of this specific discussion. And perhaps in a subsequent video, we're going to look at a 3 by 3 matrix and some of the strategies that we can use to find the inverse. So if we have a matrix A be given by these 2, 5 and 1, 3. So let's apply our formula, which are defined as the inverse of A is given as 1 over A D minus BC into DA and then BC negatives given as such. So therefore, we're going to have the inverse of A given in terms of 1 all over. So if our matrix is going to be A, B, C, D, so this is a general representation that I'm going to use in trying to define this matrix so that we can be able to use the properties of this formula. So we're going to have AD, which is 2 into 3 minus BC. This is a BC, which is basically 5 times 1, 5 into 1. And this is going to be given as DA. So our D is 3, which is going to be 3. And then A is going to be 2. So 2, we're going to interchange, swap the positions for 2 and 3. And then this specific element for B and C are going to maintain the position, but they are going to change their specific values for negative from positive in that specific order. So this is going to imply that this is 1 over 6 minus 5, and then this is going to be the 3, negative 5, negative 1, 2, and then this is 1 over 1, and basically then therefore we're going to have these specific matrices, or matrix multiplied by 3, negative 5, negative 1 over 2. So 1 times a number is going to be that specific value, implying that Basically, then our inverse for that matrix is given as 3, -5, -1, 2 given, and that's and that's one of the applications of the laws, the specific law, which simple law that we have, of course, explained for defining the concept of the inverse of a matrix. Now, in our next discussion, we're going to look at the involvement of our cofactors and the classical adjoint, and that's going to form our second part of a strategy of finding inverses of matrix of square matrices for 2 by 2 and 3 by 3 given as such. So catch us in our next video, and kindly subscribe to our channel so that you can be getting more updates on various discussions on subjects in mathematics, physics, chemistry, and biology. So that is it for now, guys. Bye, God bless you. Catch us in our next video.